Okay, Izzy, this is for you. I know you have to do this test coming up soon, and Mum asked me if I could just write some answers for you, but I thought it might be helpful if I show you the process that I use when doing this sort of stuff. It might help you. I'm not sure where you're at with your maths, so it's hard for me to know exactly what level, but I'll just show you how I would do it, and if it doesn't make sense, then maybe we can talk about it. Okay, so Jen, I'm just going to read the question. Jen has large paper clips and small paper clips. Okay, so I can see the large ones and the small ones. He's weighing them using kitchen scales. 3 large paper clips and 1 small paper clip weigh 10 grams. So that's that one. 3 large, 1 small. And Jen removes one of the large paper clips. The remaining paperclip weight is 7.2 grams. So that's shown there. How much does 1 small paperclip weigh? All right, so we've got to kind of work it out. The first thing that I would do with this kind of thing is it's about finding the information that we are given to work out the information that we're not given. All right, so we know we could start out just by working out what we do know. So we know we've got 3 large and 1 small paperclip. I'm just going to put equals 10 grams. And I also know 2 large and 1 small equals 7.2 grams. So now we need to now the question's asking us how much does 1 small paperclip weigh? We can use this information to work out what that would be. So the difference between this one and this one is 1 large paperclip. And it's also, we could work out the difference in weights. So we could have 10 grams, take away 7.2 grams. Oh, I haven't drawn that very well. I'm going to draw that again. 10 grams, take away 7.2. Now I've just done that like that. So that's 10.0 take 7.2. And we're going to work it, and we've done that to work out the difference. So I can't take 2 from 0, and I've got none in the ones place, but I do have 1 in the tens place. So I'm just going to rename that 10 ones, and then I'm going to rename that as 9 and 10. 10 take 2 tenths is 8, 9 take 7 is 2, and I don't have any. So the difference is 2.8 grams. So we know 1 large is 2.8 grams. And that's going to help us because on here we've got 2 large and 1 small, and it's 7.4. So we could work out 2 large, if I could spell, is 2.8 plus 2.8, which is equal to 5.6 grams. So the total here of 2 large and 1 small is 7.2, and 2 large by themselves is 5.6. We can work out 1 small by doing 7.2, take away the 2 larges, which is 5.6. 2 take 6, I can't do like that. So rename one of the wholes as a 6. 12 tenths take 6 tenths is 6 tenths. 6 take 5 is 1. So 1 small is 1.6 grams, and then that's answer B. So just one is B. That's my answer. Let's have a look at another one. All right, so lucky packs. Let's have a look at this one. Cards for a trading card game can usually be purchased in packs of 10. The pack costs $6 each. As a special offer, the pack contains 2 extra cards for no extra cost. What is the difference in price per card between the 10 packs of 10 and packs of 12? Okay, so that's kind of a tricky situation because they're asking us the difference in price per card. So the first thing we need to work out is how much the cards cost when they're in packs of 10 and how per card, and how much the cost per card is when they give you the extra one. So let's work out. Let's start again by working out all the information that they give us and just writing that down. That's a really good place to start. So 10 cards are normally $6. And then we'll call that scenario 1. And scenario 2 was 12 cards for $6, same thing, is going to be scenario 2. So scenario 1 is going to be $6 divided by 10, which is going to be equal to 60 cents. And so that's scenario 1. Scenario 2 is going to be $6 divided by 12, which is going to be equal to 50 cents. Now, if you're not sure about calculating these, we could talk about that separately. But for this video, I'm just going to assume that you know how to do that. So 60 cents and 50 cents. So once we've got that, that's scenario 1. Oh, that's, yeah, scenario 2. So now we can easily see the cost difference. If we go back to the question, it asks us what is the difference in price per card, is if that one's 50 cents, that one's 60 cents. The difference is 60 take 50, which is equal to 10 cents. So 10 cents. I guess the important thing with these is it's a really good place to start by writing out the information that they give you and then working out what the thing is that you're trying to find out. And then just sort of, you've got to try and figure out how you get from what they've given you to what they're asking you. All right, let's have a look at another one. Pizza versus sushi. Okay. So that was question number 2. This is question number 3. Pizza versus sushi. Okay. In Mrs. Biazza's class, sounds very Italian, 16 students study Japanese and 8 students study Italian. The students made the following pie graphs. So this is for the kids that prefer pizza. They have a pizza covering and the sushi ones have the sushi covering. So I'm just looking at that. And then it says students studying Italian, they prefer pizza and they prefer sushi. And then out of the students that study Japanese, most of them seem to like sushi and a little bit pizza. So that's what the information they're telling us. And then they're saying, what is the correct graph for the whole class? Okay. So once again, let's write out what we've known. Let's start out by writing what we know. Just going to move that. We've got 16 for Japanese. And it looks like out of those, 3/4 of them like pizza and 1/4 sushi. And out of the 8 students for Italian, 1/4 like pizza and 3/4 like sushi. All right, so what is the correct graph for the class? So what we need to work out is we're trying to make one pie graph now. So we need to work out how many out of the whole class like pizza and how many out of the whole class like sushi. So what we can do is we can go 3/4 of this 16 like pizza. Now 1/4 of 16 is, if you do 16 divided by 4 is 4. So 3/4 is going to be 12 students out of the Japanese students who like pizza. And 4 of the Japanese students like sushi. And out of the 8, 1/4 like pizza. So that's going to be 2. And 3/4 of 8 is 6 like sushi. So for the pizza students, this one and this one, they're the pizza students. So we've got 12 and 2, which is going to be 14. And sushi, we've got, I think it's a different color, 4 and 6, which is going to be equal to 10. So now we've got a situation where we've got a total 14 kids liking pizza, 10 kids liking sushi, and we could have a total of, didn't write that very well. Total is 24, equals 24. All right, let's divide this pizza up into 24 pieces. So 2, 4, and then we've got to make it into 12. So this is where you've got to get a little bit tricky. Okay, let's go into 8. And then I've got to divide each one of those 3. Let's just do maybe this one into a third. I'll use a different color. All right. So that's so each one of these pieces is for 3 students, and this one I've just broken up. So for 3 students, pizza, let's say like this one, pizza is these 3. So 3, 6, 9, 12, and then 13, 14. 13, 14, that's going to be all the pizza students. And then the sushi students are going to look like in green. We've got 10, so it's going to be sushi 3, sushi 6, sushi 9, and then sushi one more 10. So it's going to look like that. We're going to have pizza, pizza, pizza on that part and sushi on that part. So sushi is going to be, look, it's about, well, that's a quarter. That's 3/8, and then just a little bit more than 3/8. So looking back over here, it's not Oh, hang on. No, that looks about right, actually. Oh, no, that's sushi, not pizza. So, no, it's just a little bit of sushi. And it's definitely not that one. It's definitely not that one. That one looks the closest. I'm going to go with C for that one. Remember, if you don't know, you can always go to the answers and sort of try and work it out just from there too. If we know that 16 doing Japanese, that's most of them. 3/4 of them like pizza. So that's most of the kids. Most of the kids are going to like pizza. So anything with more sushi, we could rule out straight away. And then we're left just with those two. And yeah, so just another way that you could approach the problem. Right, question number 4. Let's have a look at that one. Get into gear. This one was a bit of a tricky one. All right, so 3 gears are shown below. 1, 2, 3. When any one gear is turned, the other 2 also turn. Okay, so as that one turns, these are going to turn. I'm just looking at that. That kind of makes sense. The gears only turn in the directions shown by the arrows. Okay, so that kind of makes sense. As that one goes that way, that one's going to push through that way. And same over here. Okay, each gear has a number printed on it. As the gear turns, a different number appears in the circular window in front of each gear. In the starting position, each gear has 1 in the window. Okay, that's what it shows here, 1, 1, 1. When gear A makes a full turn so that 1 is in the window again, gears B and C each show 8 in their windows. All right. So let's have a look at that. So if that's going to go 1 and then 2, I'm just counting the numbers that go through in the teeth. So it's 2, 2, 3, 4, 5, 6, 7, 8. So for 8 turns, it gets 1 back in the window. 1, 2, 3, 4, 5, 6, 7. I was going to say 8 doesn't sound right to get 7. So yeah, 7. 1, 2, 3, 4, 5, 6, 7. Cool. And then if this one turns the same amount, it says that it's going to have 8 in the window. Let's just check that. 1, 2, 3, 4, 5, 6, 7. Yes, so that number will come all the way around to there. And this one will also have 8, so it's going to go, it's turning this way. So it's going to go 1, 2, 3, 4, 5, 6, 7, and it will have that 8 will have come round to that window by that point. All right, so let's see what they're asking us. From the position, starting position, gear A makes 3 full turns. Okay, so let's write that down. Gear A, 3 turns. So that what number do B and C now show in their windows? Okay, so let's work out 3 full turns. It takes 7 for it to do 1 turn. So 3 turns is going to be equal to 21. So it's going to do 21 movements in 3 full turns because there's 7 in each turn, which is 3 times 7. what we now have to work out is what's gear B going to do in 21 turns. So looking at the numbers here, it's going to go, gear B takes 10 to do one full turn. So one turn is going to be 10, 10, 2 turns, and this is gear B. 2 turns is going to be 20. So 20 is going to get us back to the starting point. And then we've just got to go one more. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, so that doesn't look right. So let me do that again. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2. And one more. So that one's going to show a 2 in there. So it shows a 2 in the window. And C, it's got to go 21. So one turn is going to be, has 9. 2 turns, 18. And then but we want to go 3 more. So 9 gets us back to here, 18 gets us back to here. And then we've got 19, 20, 21. So it's going to be a 4. Shows a 4. So we've got A, B, 2 and 4. That's the one we want. So our final answer is B. That's for question number 5. Question number 6. Still going to be to do with the gears. From the starting position, gear A is turned so that gear C completes one full turn. What number does A now show in its window? All right, so this one is seems very tricky. Like, oh, how do I know that? And but what we could do is we could kind of work backwards for this, is I think what they're kind of going to get us to do. So this one has to do one full turn. All right. So let's just start by writing that. Gear C, 1 turn, I'll just put full turn, is going to be 9 of the little turns, 9 cog turns. All right, if this one does 9 cog turns, this one is going to do 9 cog turns too. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the 3. So it's going to be gear A will be 3 in the window. Also B. What I hope you've seen now, Izzy, is that it's really helpful to have a piece of paper. It's really helpful to write down the important information of each question as we go. Write down what they tell you, and then that'll help you working out what you need to work out. Otherwise, it's just too much information for the brain. So as we can unpack some of the information out of the brain onto the page, that's really the way to approach these problems. Okay, let's have a look at this one. Question 7. After 7 full turns of gear A from starting position, what number does gear B show in its window? Okay, so 10, so it's number 7. I'll just bring the question back. Oh, that's not it. One. 2. Right, okay, here we go. So that's, I'll just bring the gears back. So we've got 10 full turns of A. So 10 times A has how many? 7. 10 times 7 is going to be equal to 70 turns. 70 gear. I don't know what you call these, gear point turns, I'll just call them. Or gear, how about we call them teeth? Gear teeth. Turns. And so if we do 70 gear, so it's going to take 10 for this one to go around once. So once will be 10 turns, 10 of these teeth turns. Twice, it's going to be 20. 3 times will be 30. 4 will be 40. 5 will be 50. 6 will be 60, and 7 will be 70. So if that turns 70 times, that's going to get right round to the same place. So it's going to give us a 1. So gear B, if that does 70 times, 10 times will be 1, 20 times will be 1, 30 times, 40 times, 50 times, 60 times, and 70 times will all be a 1. All those will be a 1. So this is the one they're asking us about. So it's going to be a 1. A. And let's go to number 8. How many full turns of gear A from the starting position, are needed for all 3 gears to return to the starting position? Okay, that's a bit more tricky. I think it's going to be 7 times 10 times 9. Seven times 10 is 70 times 9. 7 times 9 is 63, so we've got 630. I'm going to go with 630. I don't think, I'm just trying to think about it. I don't think it's going to have that before 630 turns, because otherwise one of them will be out. So for it to do all of them fully to go around, I reckon 630 times. How I work that out, I don't know. That's a bit more difficult to explain. How do I explain that? I'll come back to that one. That's always also another good idea to, when you're working through things, if it's difficult, sometimes good just to come back. All right, zoo. Now, I've been told zoos are against mum's religion, but so if you get a question like this, you can just say it's against my mum's religion. No, I'm just joking. You can't say that. You have to do it. Anyways, all right, here we go. Zoo display. Zoo has 6 animals, each of a different species. The zoo has a number of displays that can hold up to 5 animals. Okay, so I'm just picturing that in my head. The zoo has the displays, they can hold 5 animals each. This symbol indicates animals that cannot be displayed together. All right, I'm just going to give you another little hint here. Okay, whenever we're going through these questions, when you're reading them, reading them is really an important part of this situation. as you read, and I know you're a real good reader, make sure that you understand and can visualize each of the pieces of the question as you're reading them. Just ask yourself, does that make sense? Does that make sense? Does that make sense? And go back if it doesn't. So that's what I've done with that first one. A zoo has 6 animals. I'm thinking, yeah, okay, has 6 different kinds of animals. Each of a different species. Yeah, that makes sense. The zoo has a number of displays that can hold up to 5 animals. Yeah, okay, I can picture that. They've got some different enclosures. They can have 5 animals each. It's a bit weird, but this is just a maths question. Anyways, that symbol, the no entry or whatever symbol, indicates that animals cannot be displayed together. So we've got a little graph here, right? And it's got all the different animals. We can see the 1, 2, 3, 4, 5, 6 different animals and the same animals down the side here. So I'm just looking at the information that they're giving and I'm just trying to make sense of it. Then they've got these little red things where they can't go together. So this blue koala, and I think that's a warthog, they can't go together. And this guy said, all right, that's one. Yep, makes sense. And it's kind of a mirror image down there if you can see, because anyways, it's not really important. Which of the following is a group of animals that can be displayed together? Okay, well, this one is right. I would just say, this is often a really good tactic, is just to try out the answers. Okay, let's start with A. I've got a warthog, a koala, and a giraffe. All right, can we do that? A warthog and a koala? No, that's already a cross, so it's not that one. Let's look at B. Warthog, giraffe. Okay, warthog, giraffe. Yes, that seems okay. Okay, can we have giraffe, can we have warthog and... is that a meerkat? Warthog, meerkat, yes, that looks okay. And can we have giraffe and meerkat? Giraffe and meerkat, no. Okay, so it's not that one. Okay, koala and, is that a cow? Koala, cow, it seems yes. Koala, giraffe, seems yes. And can we have cow, giraffe? Cow, giraffe, no. All right, so it's probably going to be this last one. Let's just check. So koala and cow. Koala, cow, yes. Koala, meerkat, yes. Cow and meerkat. Cow, meerkat, yes. Okay, so it's going to be D. It's our last one. 9 is D. All right, so there's a bunch more questions there. I'm not going to go through all of them. Oh, this next one's hard. I'm going to go through this one last one, okay? And then after that, I'm going to get you, I think it's good if you try some on your own, and then we'll see how you're going with it. This one, all right, I'm just going to get a new piece of paper. Unknown, okay. This one, okay, this again is the one that we're going to have to read real carefully because it's tricky. And the most tricky part of it is actually interpreting the language that they're using. So let's just have a look at it. In the equation below, okay, I'm looking for some equations. I think that's what they're talking about here. Equations below, yep, makes sense. This symbol always represents the same mathematical sequence. Okay, thinking what is a mathematical sequence? The sequence is made up of one of the basic operators, and it tells you what they are, plus, subtraction, multiplied and divide, followed by a positive whole number, followed by another one of the basic operators. For example, 3, and they haven't really, so what they've done here is they've just given you, so they're giving you 2 examples, and they're saying this sign represents, that's in place of a number, and then one of these signs, and then another number. And we have to work out what they are. So let's have a look for this first one, if we can work that out. So we've got 3, and then we've got, oh no, I've done it wrong. That's not right. It's actually the other way around. Get rid of that. This means, so it's going to be that plus times or divide, then the number, then another, yeah, that's better. That makes more sense. If I'm not sure, I can go back and check. Okay, this always represents the same mathematical sequence. So this is going to be a mathematical sequence. The sequence is made up of a basic operator. Okay, so one of those, followed by a positive whole number. A whole number is going to go in there, followed by another one of the basic operators. One of those. Okay, for example, 3, so we need to work out 3 something, put a number here, something equals 4. So I'll put circles in for those. So what do we need to do? We could try 3. Okay, so what would 3, let's try 3 plus 1. Take away, what would that, so 3 plus 1 would be 4. Oh, that's not going to work already. Take away 0 equals 4. So that would make sense for the first one, but let's see if that makes sense for the second one. 4 plus 1 would be 5. Take 0 is 4, so that's not right. So we'll try, that's not it. Try a different one. And you've kind of, it's just, I think what you're supposed to do here is just try some different things you've got to kind of solve this problem. Now I'm thinking 3. Going to make this bigger. I'm just looking at the relationships here. So I'm thinking 3, I know 6 is kind of related to 2, 4, 6. So I'm just going to go, my intuition kind of takes me to this. I don't know exactly how to explain how I choose this, but the answer I think is 3. So it would be 3 times 2, which is going to make it 6. Take 2 equals 4. So this part is the part that we've added in. And if we try that same thing with the next one here, 4 times 2 take 2 equals 4. Notice that this is the same. We've got 4 times 2 is 8. Take 2. Oh, that's not right. Okay, that's not it. Nope. All right, keep trying. So I'm going to think of another one. I've got... Oh, no, that I see why that's not right. That is where I went wrong there, is that bit was wrong. If I do write it here, 4 times 2, take away 1. So 4 times 2 is 8. So this part is the same as this part. Four times 2 is 8, take 1 is 7. So yes, that one works. So this sequence works. what is 3? So then they're going to ask us to apply what we've learned here into here. So we've got to write that out as 3, and then we've got the hash, so it's times by, let's do it in this, times by 2, take 1, outside of the brackets of 2 times 2 take 1, oh, not 1, no, it shouldn't be the 1, sorry, done that wrong. I'm just going to get rid of that. I don't know if this is helping you, probably not. I could have done this a bit better, but anyways, that's it. Take, and then that should be a 1. So there we go. Times 2 take, times 2 take in blue, the rest is in, and then we've just got to solve that. So let's have a look. 3 times 2 is going to be 6. Take away, inside the brackets, 2 times 2 is going to be 4, take 1, and then we've got to work that out. 6 take away 4 take 1 is going to be equal to 3. 6 take 3 is going to be equal to 3. Is that one of our answers? Yes, it is. What is that? 3. And then 11. Oh, go on, I'll do one more. Times 2 take. Remember that this thing was meant times 2 take away. So then we've got another one, question number 11. It's going to be 4 and the hash thing times 2 take 1, and that's all in brackets rather, times 2 take, open brackets, 5 times 2 take. This is actually very hard. I think if you got this right in a test situation, you would be doing extremely well. But I'm guessing that not a lot of people are probably going to get this right. I think this is to really find, anyways, we'll finish it. But okay, so we've got 4 times 2 is 8, take 1, so we've got 7 times 2, and then take away, inside the brackets we've got 5, 5 times 2 is 10, take the square, equals 9, and then we've just got to do algebra to solve this. So we've got 7 times 2 is 14, take away 10, and then take negative, so that's going to be plus what's in the box, equals 9. 14 take 10 is going to be 4, plus what's in the box is going to be equal to 9. What's in the box, if we take 4 from both sides, is going to be equal to 5. So there we go, C is 5. I reckon that's very difficult. And I think if you could do that, you'd be doing extremely well. But anyways, there's a bunch of things. There's more to continue. If you want more help with it, let me know and we'll do some more. Also, keen to know if that was helpful or not. Good luck, Izzy.